My name is Or. I work at Tumblr. I work on our creative tools team. We're responsible for how you post stuff on Tumblr. But we also, as Android engineers at Tumblr, we work on basically every part of the app. And we're hiring if you're interested. Thank you for coming to this talk. If you're interested in learning how to create cool icon animations, this is the talk for you. So my fascination with icon animation started right around the time I graduated from university, and I was trying to learn Android. And this was around the time when Jelly Bean was released. While I was trying to kind of figure out how life cycles and fragments work, other more experienced developers started introducing navigation drawers to their apps. And early implementations adopted this kind of interesting animation. And it was kind of a cool animation, pretty informative, but it wasn't like mind-blowing. And then a little bit later, Google introduced material design. And with that came the spinning, like the spinner menu to arrow animation. And that kind of like blew my mind, and I felt like I had to know how they implemented it. So I dug around and I found action bar drawer toggle class, and I opened it and I looked around, and it turned out that there wasn't any magic involved. It was just a lot of math and a lot of kind of trying to figure out where in the animation you are and just drawing directly to the canvas. So I closed the file and I figured I'll never really have the time to write something like this. It was just too complex. And then the Timely app came out. And if you don't know, the Timely app is, it's a pretty cool clock app with everything you'd expect from a clock app, like alarms, timers, stopwatch, etc. But it also had a ton of animations. There are numbers that morphed, there were lines that changed size and color, there are bubbles that moved for no apparent reason. But it was an eye-popping extravaganza. And again, I felt like I needed to know how it was done. So I Googled a little bit, and I found this great article about number tweening. And it described that the numbers that they were using, the text, wasn't really a font, but actually paths that were drawn directly to the canvas. And there were, it explained how it used control points and extra control points, and then morphed the shapes. And it was super complicated and interesting. But ultimately, it seemed too hard, and again, not something that you could figure out in a day or two. But by digging into all of this, I learned that it's these small things that, are what kept me coming back to this app. And I learned that like icons can be more than just icons. Icon can be, it's more than just the sum of its parts. It can be very informative. It lets the users know what will happen if they click it. Or it can let them know, hey, there's more new stuff if you click me. And it doesn't have to be really complicated. We've seen countless examples of this. It can be just a simple red heart that says you've already liked this image or post. It can be a simple badge that says, hey, there's 3 new messages for you. One of my favorite examples is the lock screen on the Robinhood app. It's just such a simple and informative implementation. When scanning your fingerprint, if it fails, the fingerprint morphs into this exclamation mark saying, it didn't work, try again. And if it succeeds, the entire shape breaks apart and the login screen fades into the main screen. It's fantastic. So how do we actually build cool animations like this? Well, first we need to understand what vectors and SVGs are. So SVG, or the Scalable Vector Graphics format, is an image file format that's specifically designed to be small, meaning that An SVG is much smaller than the corresponding PNG or JPEG file. They're also scalable, meaning that you won't lose quality by displaying it on a larger screen or a more higher resolution screen. And this is especially important on mobile devices because it means you only have to ship one version of your image instead of multiple to support different resolutions. And the other great benefit of SVGs is that they let you animate specific components of the image at runtime. So this is what an SVG file looks like. And as you can clearly tell, it's not very human readable. But as Android developers, we know how to read XML files. So it's pretty obvious that there's an SVG element, and some of its attributes kind of make sense, like the description element. There's a G element that has a color hex value, but it's not really obvious like what the shape of this is. So let's kind of dig into some of the more important parts. SVG uses a simple coordinate system with the top left corner of the canvas being 0, 0. And it supports transformations to this coordinate system. And those can be pretty simple, like rotation, scale, and translation, but they can also be complex, like skewing. And those kind of let you do very specific effects over the shape you're drawing, but they're not super useful for us Android developers. And then the other property you should know is the view box. And the view box defines a user space for drawing. So whatever your actual coordinate system doesn't really matter because you draw in this view box, which is just a basic X by Y. So given some size, we can adjust our coordinate system to a different, simpler value. For example, we can have a 4 by 4 grid, or a 12 by 12, or a 48 by 48. Okay, so now that we have our grid, how do we actually draw something? Well, SVG has many different commands that it can use, but arguably the most flexible and most interesting is the path element. Paths represent the outline of a shape, and it can be either filled, stroked, or used to clip other paths, or any combination of the three. The D attribute, also known as the path data, is a string of letters and numbers that describe commands for the computer to follow when drawing. Path data typically dominates SVG file, and therefore it's compressed as much as possible. Commands are one letter long, followed by 0 or more parameters per command. And white spaces are omitted whenever possible. So in this example shown over there, you can omit all the white spaces as well as the commas, and it would still be a valid path. A path can also contain multiple segments. The fill and stroke attributes are used for setting the colors, are used to set the colors of the shape, and the fill rule is used to determine the strategy used to fill the shape. And that's pretty important, and I'll get back to it later. Commands always start with a letter, followed by, like I said, 0 more parameters. Commands can either be lowercase or uppercase, with the difference being that uppercase commands are using absolute coordinates, while lowercase mean relative coordinates. And a nice analogy to keep in mind as you read path data is to imagine drawing on a piece of paper with the current point being the location of your pen. So the first command, the move to command, establishes the new current point. The effect is as if you lifted the pen off the paper and moved it to a new location. And every path segment has to start with the move to command. The line to command simply draws a straight line to point XY. And there's two variants to the line to command, H and V. and those are to draw horizontal and vertical lines. So they let you save one character. The curve2 command draws cubic Bezier curves from the current point to point xy using two sets of control points. And then there is an S command, which is a shorthand that assumes that the second control point is a mirror of the first one. There's also Q and T commands to draw quadratic Bezier curves, and an A command to draw elliptical arcs. And the close path command draws a straight line from the current point to the starting point of the current subpath. The stroke attribute defines the color of the path, while the stroke width defines the width of the path. And the fill attributes describe the color used to fill the shape. The fill rule describes the strategy used to fill the shape, and we'll come back to this in a bit. VectorDrawables are Android's version of the SVG format. It's a small but powerful subset of the SVG format, of the SVG spec. And most importantly, it uses a different syntax that would be more familiar to Android developers. So every vector drawable also uses a Cartesian coordinate system. Vector drawables use viewport width and viewport height, which are equivalent to SVG's viewbox property. However, they're specified as x and y values rather than start and end coordinates. And the width and height are the intrinsic width and height of the drawable. And this is used when you want to support pre-lollipop devices. It generates PNGs at the right size, specified by these two properties. The path data element is Android's version of SVG's SVG's D element. And as you can see, the attributes are very similar. Path data is the same as the D attribute. Fill color, and stroke width are pretty self-explanatory. So this is what a sample vector drawable looks like. This particular one I just copied from the Android documentation, and it's just a battery indicator. The top level is the element, the vector. And inside the vector, we have two path elements. Notice that the path also has a name attribute. This is useful when you want to animate the vector, but it's also useful because reading the path data doesn't really tell you anything about the shape. And then one other thing I want to mention is that the order that you place the paths within the vector matters for the Z ordering when it gets drawn. So in this case, the little lightning icon appears on top of the battery and not behind it. All right, so how do we actually make these? It turns out that it's very easy. Android Studio has a tool to create vector drawables for you. It lets you pick from like hundreds of existing material style icons, as well as import your own SVGs. So let's say you wanted to import this SVG that you got from your designer. You open up Android Studio, you start importing, you go through all the steps, and then when you run it on a device, you get this. And you ask yourself, what happened here? Why does the SVG have the hole in the shape and the vector drawable doesn't? Well, it turns out that the problem is the strategy used to determine whether or not to fill the shape. The SVG is using something called the even-odd fill rule. And as it turns out, that's Android only started supporting even-odd in version 24, Nougat. So the question that you would ask yourself at this point is, am I out of luck and I just have to go back to using JPEGs or PNGs? And the answer is no, because I have a solution. Use min SDK 24. You'll be targeting about 95% of users in this room. All right, I have a real solution. Two, actually. We'll start with the hard one. you'll need to convert the even-odd fill rule to a non-zero fill rule. But before you can do that, let's understand what those even are. So we start off by drawing a ray from any point in the canvas towards infinity. And in order to determine, we do that in order to determine how many paths we cross. If a path crosses in one direction, we increase the count by 1. And if it crosses in the other direction, we subtract by 1. For the even-odd rule, if the total number of paths crossed is even, the point falls outside the shape, and therefore it doesn't get filled. And if the point is inside the shape, therefore it's filled. And we repeat the same process for all points to determine what gets filled and what doesn't. For the non-zero rule, if the total number of paths crossed is 0, the point is outside the shape and therefore not filled. And if the total is not 0, whether it's positive or negative, the point falls inside the shape and therefore it's filled. So in our case, in order to fix the vector that we have, we need to reverse one of these subpaths, reverse the direction that it goes in, such that the non-zero rule is satisfied. Now that's the hard solution. What's the easy solution? Well, the easy solution is to use the support library, which backports the even-odd rule all the way back to ice cream sandwich, as well as supporting AnimatedVectorDrawables, again, all the way back to ice cream sandwich. And speaking of AnimatedVectorDrawables, AnimatedVectorDrawables take vector drawables and make them animatable. A vector drawable assigns each animated path or a group of paths a unique name, and the animated vector drawable maps that, uses those names to map one path or a group of paths to object animators. So AVDs are just a simple XML resource file that are just like shape drawable or stateless drawable. You pass it in your, in order to actually create an animated vector drawable, what you do is you pass it your vector drawable resource, and that's also used as the start state of the animation. Next, you define one or more mappings between a path or a group of paths and an animation. Pretty simple, right? But what can we actually animate? Well, it turns out that there's a bunch of things you can animate this way. There's basic things like animating a color change, or the stroke width, or like the scale, or the transparency. But there's more interesting animations I want to show you. The first set of animations I'd like to discuss is the group transformations. These are animations that you apply to a group of one or more paths that animate the unit without changing its shape. So let's say you have a simple arrow that you got from your designer. And you want to make this, all right, let's step forward. You have this arrow that basically flips up and down, and you want to add a little bit more motion into this state change. So one thing you can do is you can treat the two halves of this arrow as independent paths, and then you can animate them separately. And this allows you to add a lot more motion into something pretty simple. And it's a little easier to understand if we add color to each path. In this case, we rotate each path around the point of the arrow, and then we apply a translation animation along the y-axis to the whole group. And by applying a slight delay to the translation, we get this kind of more meaningful opening and then moving animation motion. The next group of animations are trimming a stroked path. So this is a very powerful property of a path, is that you can draw only a portion of it. So you can trim the path before it gets drawn to the canvas. And by animating these properties, this start, end, and offset, you can create some very cool effects. And this is actually how the material style progress bars are implemented. The horizontal progress bar has two paths that are animating on a third semi-transparent track, while the circular progress bar has one path with its start, end, and offset all animating, and the entire group is rotating at the same time. And this is actually how the fingerprint animation is implemented. In this case, there's 5 paths that are used as tracks, and 5 paths that are being filled in by animating the trim path end attribute from 0 to 1. The next kind of animation I want to talk about is, in my opinion, the coolest and most powerful animation you can do with AnimatedVectorDrawables, but it's also the hardest one to implement. And the reason that it's hard to implement is because 2 paths, in order to animate between them, they have to be compatible. And in order to be compatible, they must have the same number of drawing commands, and corresponding drawing commands have to be of the same type and the same number of parameters. So let's say we want to animate from this minus sign to a plus sign. First, we need to determine if the paths are compatible. So we iterate through the commands. The first command is valid. Then, in order to get to the same point in the minus path, on the plus path, we have to go through 5 commands, meaning that we have 4 extra commands in there. The next command is OK as well. And then again, we have to go through 5 commands in the plus path in order to get to the same command in the minus path. So what we need to do is we need to add these extra commands to the minus path without actually changing the shape, like the shape of the minus. So we determined that the path, in order to get to the second command of the minus, we need to add 4 commands to match the plus. So we do that. We repeat the process we do the same basically for the other missing commands, and we end up with compatible paths. So now that they're compatible, what does the animation actually look like? The minus is able to smoothly animate into the plus sign, and that's what we wanted to achieve. And then if you follow basically the same technique, you can get some really cool animations going. And you can get really wild with it and get this crazy animal morphing animation. And for this animation, I used a tool called ShapeShifter. If you went to Alex's talk earlier, you know all about it. That's a tool that lets you enter any arbitrary Android or VectorDrawables or SVGs, and it will do all the hard math to add all the missing points. And seriously, if you want to do this more than once, don't do it manually. It's a pain in the ass. All right. The last animation type I'd like to discuss is path clipping. Path clipping, or path clip, is a type of path that is used to mask other paths by restricting the region to which paint can be applied. Anything that lies outside the region bounded by a clip path does not get drawn. And by animating the bounds of these regions, we can create these cool effects. So this one is kind of hard to explain, so let's break it down using this blinking eye example. Well, we start off with the eye, and for now we'll just ignore the eyelashes. What we want to do is we want to generate a mask that will let us take the open eye and restrict the part of it that's drawn into this like closed arc. And then remember that anything that lies outside the region bounded by the clip path will not be drawn. So in the open state, we have a mask that encompasses the entire shape of the eye. And in the closed state, we want the mask to only cover this small arc at the bottom. Next, we use a path morphing animation to animate the change between the open and closed state. All right, so we started with the eye, and by animating a mask, we can create this blink effect. But what about the eyelashes? Remember that anything that lies outside the mask or the region bounded by the clip path does not get drawn. So how do we actually get those to draw? Well, a nice property of the clip path is that it only affects its siblings within a group. So if we structure our vector drawable such that the eyelashes are not a sibling of the mask, we're able to draw the eyelashes outside the mask area. And what we get when we put it all together is this blinking effect. Last thing is, how do we actually get these to start? Well, AnimatedVectorDrawables actually implement the animatable interface. And what that means is all you have to do is grab a reference to the drawable and call start or stop. But if you're lazy like me and you want to make this even easier, you just define an animated selector in XML. You pass it the animated vector drawable file, and it does all the magic on its own. And if you want to learn more, there's some great resources about ShapeShifter, about various icon animation techniques. And this YouTube link is a great explanation of what Bezier curves are and how they work. And when I created these slides, I didn't expect to be the last presentation. So you should watch these 2 talks that already happened. But there's videos. And that's it. Thank you. And if there are any questions,
Hi, I had a question about SVG to vector drawable conversion to Android.
Yeah.
So like recently, like we had designers design these like nice SVGs and stuff, but then there's some properties that don't work on Android. So is there like a subset list somewhere saying what is possible in that?
Sadly, it's not very well documented.
Yeah.
And I looked for hours trying to figure out what is and what isn't supported. And the best way to find out is just to try.
Okay. I actually did find one way. If you look at the actual source code for the
you have to look at the source code.
Saw, but I would think there would be like a more proper way.
But it does get updated often, and it gets better.
Okay.
So if you use version 3.1 of Android Studio, it's a lot better.
Okay.
But there's still stuff that's not supported. Specifically, fonts are not supported.
Yeah, like masks, text, a lot of things. So. Okay, thank you.
Have you done any kind of offset-based animations with?
I'm sorry, there was a little noise.
Have you done any kind of offset-based animations which are like not time-based, but say based on a slide value?
Like ones you can control the progress of the animation?
Yes.
So with AnimatedVectorDrawables, you can't do that, unfortunately, but there is a library from Airbnb called Lottie that lets you do that. And there's one from Facebook called Keyframes, I believe, that also lets you do that.
So when you're playing with the values for like the paths, the points, like do you use another tool for that? Because as far as I can remember, you cannot really do real time on Android Studio, right?
To adjust the...
Yeah, to adjust the...
You can. It's very resource wasteful. But you can do it on Android Studio, but I prefer using ShapeShifter. It's just very, very intuitive.
Since you mentioned Lottie, I was wondering like if you could give a little bit more of your experience using it, and like would it be a good alternative, even if you had like non-animating SVGs, just to support like the broader set of like exported SVGs?
Well, Lottie exports from After Effects, so it's not SVGs, and it's specifically for animations. I don't have much experience with it beyond just playing with the sample app, but as far as just supporting regular SVGs, VectorDrawables are very good, and they're obviously the first-party solution. And they are getting better over time, both like the performance and the things that are supported. All right, well, thank you.